of all points equidistant from some point called the center of the circle. That distance is called the radius of the circle. So a circle is the locus of all points equidistant from some fixed point called the center of the circle. And that fixed distance is called the radius of the circle. So let me determine the equation of a circle centered at the origin. I can do that using Pythagorean's theorem. So Pythagorean's theorem just says that a squared plus b squared equals c squared. And so suppose I have some point xy on the circle, and suppose that this circle is centered at the origin and has radius r. Then I have that, well, a squared plus b squared is c squared, x squared plus y squared equals r squared. And so that is the equation of a circle centered at the origin of radius r. The standard form for the equation of a circle is, well, I can just figure that out by translating to the point hk. And so if I translate to the point hk, then, well, I replace x by x minus h and y by y minus k. Yeah, whatever. Okay. Okay, sorry about that. Yeah. Okay. I'm just great. So don't do that to me. Okay, so let's translate. So the circle centered at hk of radius r has the form x minus h quantity squared plus y minus k quantity squared equals r squared, just by replacing x by x minus h and y by y minus k. Oh, I hate you. And so the equation of a circle centered at hk of radius r is x minus h squared plus y minus k squared equaling r squared. If r is equal to 1, then we call it a unit circle. Okay. Okay, good. Page 39. In problems 9 through 12, can you scroll up a bit? Oh. Like that? Then I'll be quiet while you... Oh, by the way, these lecture notes are online. It says just lecture notes for this particular section. Page 39. In problems 9 through 12, find the center and the radius of each circle. Write the standard form of the equation. Okay, so I have here a circle through 2 points, 2, 3, and 0, 1. And so this notation here says that this is going to be a diameter of your circle. A diameter is a line joining 2 points on the circle that passes through the center of the circle. The center of a circle is located at the midpoint of a diameter. And so the center is the midpoint of a diameter. And so the center is just found by finding the midpoint. X1 plus X2 over 2, Y1 plus Y2 over 2. So let's just add the X coordinates. 2 plus 0 divided by 2. 3 plus 1 divided by 2. And so 0 plus 2 is just 2 over 2, 1. 1 plus 3 is just 4 over 2, it's 2. And so the center of my circle is at 1, 2. Therefore, the equation of my circle is just x minus h squared plus y minus k squared equals r squared, where h is 1 and k is 2. So the equation of my circle is x minus 1 squared plus y minus 2 squared equaling r squared. I don't know r yet, but I'll be able to figure it out by putting one of these, it doesn't matter which one, into the equation and solving for r. I'll probably put the 2, 3 in here so that I don't have negatives. Why don't we do the other one? No, I did 2, 3. So I don't get negatives. And so replace x by 2, y by 3 in the above equation. 2 minus 1 is 1. 3 minus 2 is 1. 1 squared is 1. 1 squared is 1. 1 plus 1 is 2. So this r squared is just 2. So therefore, the equation of my circle is just x minus 1 quantity squared plus y minus 2 quantity squared equaling 2. Any questions about that? Okay. In problems 13 through 24, write the standard form of the equation and the general form of the equation of each circle of radius r and center hk. So they give us the radius is 7 and the center is at -5, -2. Well, the standard form for the equation of a circle is just x minus h quantity squared plus y minus k quantity squared equaling r squared. H is -5, so minus the -5 is the same as +5. K is -2, minus the -2, same as +2. R is 7, so r squared, 7 squared, 49. So the standard form for the equation of my circle is just x 5 quantity squared plus y plus 2 quantity squared equaling 49. The general form is found by just squaring this out and simplifying it. It's just a general quadratic equation in the variables x and y. And so, by the special product formula, the perfect square trinomial, a plus b quantity squared is just a squared plus 2ab plus b squared. So x squared plus 2 times 5 is 10 times x is 10x plus 5 squared is 25 plus, I'll use the special product formula again, y squared plus 2 times y, 4y, plus 2 squared, 4 equals 49. So lastly, let's simplify this. Let's write this in descending order. So I have x squared plus y squared plus 10x plus 4y plus, well, 25 plus 4 is 29 minus 49 is 20. And so minus 20 equals 0. So that is the general form for the equation of your circle. Any questions about that? Okay. In problems 25 through 38, A, find the center, HK, and radius R of each circle. B, graph the circle. C, find the intercepts, if any. Oh, so this is a circle here written in general form. And so the first thing is we want to find the center and the radius. There is, for a circle, there is no points of form. So for a circle, there's only the standard form and the general form. So this is the general form. Ax squared plus ay squared plus bx plus cy plus d equaling 0. This is the standard form for a circle. So for a circle, there's really only two forms: the standard form and the general form here. Okay. So in order to find the center of a circle, I'm going to have to complete the square. So if you remember back in your previous math classes, you're like, why did they teach us to complete the square? It's easier to use the quadratic formula. Well, it's because of this sort of thing. In order to find things like centers of circles, to do things with other conic sections, you need to complete the square. So that's really the reason for completing the square. It's not to solve quadratics, which is usually how they first present it. It's really to do this sort of thing. Okay, so let's try to complete the square. So first, I will write all the x's together. So I have an x squared plus 4x. I have a y squared plus 2y. And let's bring the 20 to the other side of the equation. So now let's try to complete the square. So I have an x squared plus a y squared. And I want to figure out what to add here in red. So I take, since there is a 1 in front of the x squared, this is a monic quadratic trinomial. And so to complete the square, all I have to do is take this number in front of the x and divide it by this 2. 4 divided by 2 is 2. So I have here a plus 2. Squared is 4. So I put a 4 here. If I have a 4 on this side of the equation, I've got to add 4 to the other side of the equation. Now, again, this is a y squared plus 2y. So this again is a monic quadratic. And so to complete the square, you just take 2 divided by 2, which is 1. 1 squared is 1. So you have to add 1 to the other side of your equation. 20 plus 4 plus 1 is 25. So this is the equation of your circle in standard form. The center is at -2, -1. And the radius, square root of 25, is just 5. Next, I want to graph the circle. Well, I have here a center and a radius. And so the center of my circle is at -2, -1, and the radius is 5. Okay, so it looks like someone sat on my circle, but it's supposed to be circular. So it's actually supposed to be circular, not like it looks more like an ellipse than a circle, but so much for my drawing abilities. Actually, on the tablet, it's really hard to draw. So it's supposed to look like a circle. Actually, if I did this on an exam, I would probably write next to it circle so that you know it's a circle. Let's find the x-intercepts. So I want to figure out when these intersect the x-axis. Well, remember, just set y equal to 0, solve for x. And so I have the equation. Just set y equal to 0 and see what x is. And so I have replacing y by 0. X plus 2 quantity squared plus y plus 1 quantity squared equals 25. And so 0 plus 1 is 1 squared, which is 1. Subtract 1 from both sides of my equation. So x plus 2 squared is equal to 24. Take the square root of both sides of my equation. So by the square root property, what's inside the square root, x plus 2, or what's inside the square, x plus 2 must equal plus or minus the square root of 24. But I can write 24 as 4 times 6. The square root of 4 is 2. And so x plus 2 is equal to plus or minus 2 rad 6. Subtract 2 from both sides of my equation. So x is equal to negative 2 plus or minus 2 rad 6. And so I have 2 x-intercepts at negative 2 minus 2 rad 6, comma 0, and negative 2 plus 2 rad 6, comma 0. To find the y-intercepts, you set x equal to 0 and solve for y. And so I'll just plug x equaling 0 here and solve here for y. So 0 plus 2 squared plus y plus 1 squared is equal to 25. 0 plus 2 is 2. 2 squared is 4. Subtract 4 from both sides. So y plus 1 squared is 21. By the square root property, I have that y plus 1 is equal to plus or minus the square root of 21. I can't really simplify this, so I'll just sort of leave it as that. Subtract 1 from both sides of my equation, so y is equal to a negative 1 plus or minus rad 21. Oh, that's horrible looking. So the y-intercepts are at 0, negative 1 minus rad 21, and 0, comma, negative 1 plus rad 21. And what else did I want to do? I want to graph the circle. Already did it. And find the intercepts. So I'm done. So I found the intercepts. Any questions about that? Okay, so find the standard form of the equation. Why is it plus or minus? Oh, the square root property. So suppose x squared were equal to 9. So what would x equal? Well, let's see. X could equal 3 because 3 squared is 9. But x could also equal negative 3 because a negative 3 times negative 3 is a positive 9. Negative times negative is positive. So you actually have two answers. You have plus or minus 3. So in general, the square root property says that if x squared equals a, then x is equal to plus or minus the square root of a. So you have two answers, the positive square root and the negative square root. Okay? Is that clear? It's just the square root property. Example. Find the standard form of the equation of the circle satisfying the following conditions. The center is at the point 4, negative 2. So here's the x-axis, the y-axis. Here's the x-axis. There are too many lines here. So this is the x-axis here, and this is the y-axis. So the center of my circle is at 4, negative 2. And it's tangent to the line x equal 1. So this is the line x equal 1. And it's tangent to this line, meaning it just touches this line. So now I want to find the equation of the circle. So the center of my circle is 4, negative 1. The distance from 4 to 1 is 3. Therefore, the equation of my circle is y minus, well, the center, 4 squared, plus x minus a negative 2 quantity squared. So x minus 4 quantity squared plus y plus 2 quantity squared equals the radius, but the radius we saw was 3. So 3 squared is 9. Therefore, that is the equation of my circle satisfying the given conditions. Any questions about that? And that was it for this section. Any questions on circles? No. Okay. Any questions about anything else? Now I can hear people. Anything? Can you go over tangent? Oh, okay. So a line is tangent to a circle if it only touches at one point. And it turns out that any tangent line to a circle is perpendicular to a diameter. So you actually have that tangent lines to circles are perpendicular to diameters. Okay, but in this case, I really didn't even need that because I have the center, and all I really need is the radius of the center. Well, if this is the line, the vertical line, x equal 1, then the place where it touches the circle is at the point 1, negative 2. The distance from 4 to 1 is just 3. Therefore, the radius of my circle is 3. Okay? Is that clear how I got the radius? This distance here is 3. Any other questions? Okay. Here's a question.